Number 10, 2009 FD. This one sits quietly on NASA's risk table, and most people have never heard of it, which is exactly why it deserves your attention first. The official designation is 2009 FD, and it measures somewhere around 160 meters across, which puts it in the range of a small sports stadium. The calculated impact probability currently sits at around 1 in 303 for a potential encounter in the year 2185. Now, before you breathe a sigh of relief at that date, consider what an object this size actually does when it hits. At 160 meters, we are not talking about a city killer. We are talking about a regional catastrophe. Depending on where it lands, you are looking at blast waves that would level everything within hundreds of kilometers. And if it hits ocean, the tsunami generated would be devastating for coastlines across entire ocean basins. It holds a Torino scale rating that keeps it on the watch list, and planetary defense scientists continue refining its orbital path every time new observations come in. The good news is that additional tracking data frequently narrows the probability window for asteroids like this one. The concerning part is that 2009 FD has stubbornly remained on the risk table for years without being eliminated entirely. Number 9. A small near-Earth object. This one might genuinely surprise you because its probability of approaching Earth is higher than most other objects on the list. It's relatively small, estimated at around 7 meters in diameter, so it would mostly burn up in the atmosphere before reaching the surface, but it is still worth noting. The reason it S included here is that calculations show a chance of up to 1 in 16 for a close encounter in the future, which is unusually high for tracked objects. Small objects like this are difficult to track accurately over long periods, and tiny changes in their orbits can make predictions vary significantly. If an object of this size did enter the atmosphere, it could create a strong airburst, releasing enough energy to damage structures or objects nearby. While it wouldn't be a global disaster, it could be locally destructive. Its place on this list is due to probability, not potential global impact. Number 8, 1979 XB. This object is interesting for a different reason entirely. 1979 XB has not been observed since its discovery year, which is precisely what makes it unsettling. When astronomers lose track of an asteroid and cannot refine its orbital path with modern data, the uncertainty in its trajectory balloons enormously. Estimated at around 710 meters in diameter, this is a genuinely large rock. If it hit, the consequences would be severe at a continental scale. The impact energy would be measured in the hundreds to thousands of megatons range, depending on composition and angle of entry. The ocean impact scenario alone would generate tsunamis capable of reaching coastlines thousands of kilometers away with devastating force. Because it has not been reobserved with modern telescopes, scientists cannot precisely calculate its current probability. But it remains flagged in historical tracking databases as a lost, potentially hazardous object. The search to relocate it continues, and until it is either found or its orbital window is ruled out entirely, it represents a genuine unknown in the planetary defense catalog. Number 7, 207 FT3, another lost asteroid. 2007. FT3 was only observed for a single day before it moved out of telescope range and has never been recovered. Its estimated size is approximately 340 meters, and calculations based on that brief observation window show multiple potential impact dates stretching through the next century and beyond, with the most discussed window being around 2024 and beyond. Now, the important clarification here is that the probability numbers assigned to 2007 FT3 carry enormous uncertainty because of how little tracking data exists. Planetary defense scientists use a concept called an uncertainty region, essentially a zone of possible positions where the asteroid could be, and when that region is large, the probability calculations are inherently less reliable. At 340 meters, a ground impact would be devastating at a regional to continental level. The Tunguska event in 1908 was caused by an object estimated at perhaps 50 to 80 meters, and it flattened roughly 2,000 square kilometers of Siberian forest. Scale that up to 340 meters, and you begin to understand why this object warrants continued concern and ongoing search efforts. Number 6, Apophis. Now we enter the territory of objects that actually captured global headlines. Apophis, officially designated 9I942 Apophis, is a 370-meter wide asteroid that became famous when it was discovered in 2004, and initial calculations suggested an impact probability of nearly 3% for an April 2029 encounter. That was one of the highest probabilities ever calculated for a large near-Earth object. And it briefly reached a Torino scale rating of 4, which had never happened before for a confirmed object. Additional observations ruled out the 2029 impact, and ruled out 2036 as well. Currently, the most closely watched date is April 13th, 2029, when Apophis will pass so close to Earth that it will actually be visible to the naked eye in the night sky, passing within the orbital distance of some of our own geostationary satellites. This close approach is scientifically fascinating because during that flyby, Earth's gravity will alter Apophis's orbital path, in ways that must be precisely measured to determine future risk windows. Scientists have ruled out any impact for at least the next century. But the 2029 flyby represents a critical observational moment. Several missions are planned or proposed specifically to study Apophis during that encounter. This is planetary defense science in real time. Number 5. 24, YR4. This asteroid generated more alarm in early 2025 than any object in recent memory, and for good reason. When 2024 YR4 was first discovered and its orbital data began coming in, calculations briefly showed an impact probability that climbed to around 3.1% for a February 2032 impact, making it the highest probability impact ever calculated for an asteroid of its size in the modern era of planetary tracking. The size estimates ranged considerably during the initial observation period, but best estimates put it somewhere between 40 and 90 meters. At the upper end, that is a regional devastation event. At the lower end, it would still be a significant airburst. The global scientific community mobilized rapidly. Observatories around the world pointed instruments at it. Space telescopes collected additional data, and, as is common when new observations refine an asteroid's orbital path, the probability was ultimately revised downward significantly. As of updated tracking, the 2032 impact probability was reduced to effectively negligible levels, but there remains a small probability window for a potential 2028 close approach interaction that scientists continue monitoring. The 2024 YR4 situation demonstrated exactly how planetary defense networks function under real pressure, and the speed with which the global community responded was genuinely encouraging. Number 4, Bennu. Bennu is arguably the most scientifically well-understood, potentially hazardous asteroid in existence because NASA's OSIRIS-REx mission actually visited it, orbited it for nearly 2 years, and returned samples to Earth in 2023. Bennu measures approximately 500 meters across, making it large enough that a direct impact would be an extraordinary catastrophe. The energy released would be in the range of 1,200 megatons, roughly 80,000 times the Hiroshima bomb. Bennu's most discussed impact probability currently centers on September 24th, 2182, when cumulative probability calculations suggest roughly a 1 in 2,700 chance of impact. That sounds small, but in the context of potentially hazardous asteroids, it is one of the most significant probabilities on record for an object this size. The OSIRIS-REx mission revealed that Bennu is actually a rubble pile asteroid, essentially a loosely bound collection of rocks and boulders rather than a solid body. This matters enormously for deflection planning because the techniques used to push a solid asteroid differ substantially from what would work on a rubble pile. NASA has years of data from that mission to inform any future deflection strategy. The 2182 timeline actually gives humanity a meaningful window to act if calculations in the coming decades confirm an elevated threat. Number 3, 29075-950 DA. This is one of the oldest tracked, potentially hazardous asteroids in the catalog, and its story is remarkable. 1950 DA was discovered in 1950, observed briefly, then lost. It was rediscovered in 2000, and when scientists calculated its orbital path using the full arc of observations, they identified a potential impact date of March 16th, 2880. Yes, that is over 800 years from now. The object measures roughly 1.3 kilometers in diameter, which moves it into a categorically more dangerous size class. At this scale, an impact would cause devastation that extends well beyond regional boundaries. The blast and immediate effects would be continental in scale, and secondary effects including atmospheric debris, climate disruption, and potential collapse of agricultural systems would affect the entire planet. The impact probability has been estimated at around 1 in 8,300 for that 2880 window. Critically, scientists studying 1950 DA discovered that its rotation rate is so fast that normal gravity and friction cannot hold its surface material together. It is being held in shape by cohesive forces between particles, essentially functioning like a very loosely packed ball of material. Understanding its physical structure is essential for any deflection planning that would need to begin centuries before the potential impact window. Number 2, 23 DW. When 2023 DW was discovered in early 2023, its initial impact probability calculations for a February 2046 collision were so elevated that it briefly held a Torino scale rating of 1, meaning it warranted careful monitoring. The estimated size of 2023 DW is approximately 50 meters, and during its initial tracking period, its probability reached as high as 1 in 432 for the 2046 date, which generated significant media attention and genuine concern among planetary scientists. The object is notable because its discovery and rapid public discussion happened in a period when awareness of planetary defense had grown significantly following events. However, the episode was valuable because it demonstrated the full public transparency of modern planetary defense tracking, with real-time probability updates being published openly by ESA and NASA as new data arrived. 50 meters striking Earth would not cause extinction, but it would be a highly destructive event capable of devastating an urban area completely. Number 1, the honest truth about extinction level threats. Here is where the conversation changes. The real extinction level threats, objects larger than 1 kilometer that could trigger global climate catastrophe and civilizational collapse, are actually the category we are most confident about in terms of current safety. NASA's planetary defense surveys have now cataloged over 95% of all near-Earth objects larger than 1 kilometer, and none of them show credible near-term impact probabilities. The genuine risk from known objects right now lies in the mid-sized range, the 100 to 500 meter objects, where our survey completeness drops significantly. We have found roughly 40% of the estimated population of 140 meter plus objects. The ones we have not yet found are the ones that keep planetary defense scientists awake. The Torino scale exists specifically to give the public a clear communication framework for asteroid risk. And right now, every known object sits at Torino scale 0 or 1. That is the good news. The work being done through programs like NASA's Planetary Defense Coordination Office, the DART mission, which successfully altered an asteroid's orbital period in 2022, and the upcoming NEO Surveyor Space Telescope plan to dramatically improve our detection of smaller hazardous objects, represents humanity's genuine attempt to take this threat seriously before we have no options left. Subscribe for the next video.